Now let's launch the STM32Cube IDE. So when you launch Eclipse based IDEs, it will always ask you to open the workspace. So now here you should give a path to create a workspace. Since we don't have any workspace, now let's create a workspace. So now workspace is a place where you keep all your projects. So now what you do now is, so create one folder in your computer. So I just created a folder course ARM Cortex MX. Okay, so in this folder we are going to keep all our projects. Okay, what we are going to do in this course. Now just copy this path and go to the IDE and paste here. So this is a path, and now let's give a name for our workspace. Okay, so just give backslash here and give a name for your workspace. Okay, now let me give Cortex MX. Okay, so that's a workspace name. Okay, so just give backslash and give the name. After that, let's click launch. Now you can see that under this path the workspace is created. The workspace name is Cortex MX, and now the IDE is getting launched. So now here it is. So this is a workspace name, and under this workspace we are going to create our projects. So a workspace is where you keep all your projects. Okay, you can create different projects under one workspace. Now first let's create our very first project, a Hello World project for our embedded target. You can click over here, start a new STM32 project, or you can also go to File, New STM32 project. So let's do that. So now it is going to launch the target selector. So please be patient. Okay, it does some network activities. Alright, so now it launched a target selection window. So from here you have to select your target. So you can select the target based on the microcontroller or based on the board. If you are using standard board produced by ST, then you can always use board selector. Or if you have any custom board designed by you based on STM32 microcontroller, then you can select MCU selector. So in this case, we are using standard board by ST, isn't it? So that's the reason I would like to go for board selector. Okay. And here just type in your board name. So I have STM32F4 Discovery, right? So which is right here. Now when you select that, you can see the picture of that board, and here there is a small documentation explaining about various features and various other things, right? And after that you can get the exact picture of that board here. You can also browse various resources and documents related to that board, such as application notes, user manuals, data sheets, etc. And you can get the data sheet from here. So here you can see that it directly downloads the data sheet from the ST website. So this is a data sheet of the board. Okay. So now if you have Nucleo board, then you just type Nucleo F446RE or whatever the board you have. Now let me go with STM32F4 Discovery. Let's hit next. Okay. I'm going to hit next. And here give the project name. So let me give the project name 001 Hello World. And after that you can select the targeted language as C, targeted binary type executable, targeted project type select empty. This option STM32Cube is used for STM32Cube project. Okay, where you can do peripheral configuration using STM32Cube MX software, and you can generate the code using the GUI. So that is not the goal of this course. Goal of this course is to learn writing code from scratch, isn't it? So that's the reason why we select empty here. And after that, click finish. That's it. So you just created your very first project. And when you create a project, you always get two folders, inc and src. So src is a place where you keep all your .c files, okay, or source code files. And inc is a folder where you can keep your application header files, okay. More on that we'll see later. So now if you open the main.c, so this is a source file where you are going to write your code, and now the main.c is pretty much empty. So now let's try to compile our code. So to compile this code, it is very simple. Just select the project and right click and click on build project, and then observe this console part here, console section, where you can see all the build logs. So let's close this. So this is a build log, and here you can see that when you build the project, the cross compiler is invoked and the source files are compiled. So this is a cross compiler which is already installed on your system when you installed the IDE software. And here you see one warning. So here the warning says that FEU is not initialized, but the project is compiling for an FEU. FEU stands for floating point unit, and we don't discuss that in this course. In order to remove this warning, you have to disable the FEU. So now to do that, right click on the project and go to properties and go to C++ build, go to settings, and here go to tool settings. So in the tool settings, go to MCU settings here. So here in the floating point unit section, since we are not using that unit, floating point unit in this course, what you can do is you can select none here, and a floating point ABI you can select as software implementation. And after that, click apply and close. And now let's try to rebuild once again. Right. So let's clean this project and let's try to build again. You can see that warning actually disappears. So that's how you compile or build the project. And if you want to download this project onto the target, you can right click and select debug as and select STM32 Cortex M C or C++ application. This option downloads the code onto the target, and also it puts the board into the debug mode. Let's try that. So before downloading a project, first you have to create a debug configuration. So here what you do is just select the debugger. Now the debug probe must be selected to ST-Link or ST-Link GDB server. So there are three different debug probes you can use. One is ST-Link, second one is Sager J-Link if you have Sager J-Link based debugger, or you can also use OpenOCD. Let's use ST-Link GDB server, and after that, interface is by default selected to SWD, so don't change that. It should be SWD. And after that, don't change anything here, access port. And after that, serial wire viewer. So serial wire viewer is one of the important feature of this IDE, and we must learn how to use this feature. And I'm going to discuss on serial wire viewer in later videos. So just enable this, and after that, that's it. You can click on apply and OK. So now the code will be downloaded onto the target. If you are using Windows, then you have to click allow access here. And after that, now the IDE is asking you to confirm the perspective switch. That means IDE is now going into the debug mode. It has downloaded the code and it is going into debug perspective. So that's why it is asking your permission to change the perspective of the IDE to debug perspective. So you can click remember my decision here and click on switch. So now the code is downloaded and both IDE and board is in debug mode. And that's how you download and enter the debugging mode, okay? So now if you want to terminate this debug session, then just click on terminate. So let's click that, and you can see that debug session is terminated and the perspective is changed back to editing perspective, or you can also call it as C or C++ perspective. Here let's write a small piece of code. Let me use printf to print some text, hello world. And after that, since we are using standard library function, so let me include the standard library header file stdio.h. Let's build the project. The project built successfully. In the next lecture, I'm going to explain how to execute this printf on our target board. So there are some techniques using which we can get the hello world text on the console. And for that, we'll be using serial wire viewer, what we call as SWV. And I'm going to discuss that in the next lecture. So just make sure that your project compiles fine, and I'll see you in the next lecture.